Okay, let's talk a little bit about probability. Why is probability something you'd want to learn about in a statistics course? Well, the reason is very simple. In psychology and sociology, in most of the social sciences, we generally select study participants or subjects using sampling, specifically random sampling. Let's say we're interested in finding out the average first-year salary for recent graduates of a college. It would be very expensive and very difficult to survey all the graduates. There are just too many of them to contact. Instead, what we would do is randomly select a sample of graduates. For example, we might obtain a list of all the graduates, select one person at random, and then say every 20th person on the list until we had a sample that was the size that we needed. By the way, that kind of sampling is called a simple random sample. The only requirement for any kind of random sample is that every element, in this case graduates are the elements, has to have an equal chance of being selected. And you can see that we meet this criteria using the procedure I just described. Here's another example. Suppose we have a new course designed to improve SAT scores. Using a similar random sampling procedure, we select some high school students and give them the course. After they've taken the SAT, we compare the average score of everyone who took the test with the average score of the group that got the course. If their course is sufficiently higher, we conclude that the course works. But, and this is a big but, what do we mean by sufficiently higher? Remember, we selected participants using random sampling. It's possible, isn't it, that purely by chance, our sample included students who have better than average test-taking abilities. In this case, they would have done better even without the course. The opposite is also true, or possible, I should say. In that case, the course might have indeed helped the students, but when we compare their scores to everyone else, then we don't see a mean difference. Now, we'll return to these scenarios later, but keep in mind the word chance. Chance is what probability is all about. Okay, so there are basically just 3 or 4 things that you need to understand about probability in order to make sense of inferential statistics. Let's take a look now at a 6-sided dice to see what kinds of things we can learn about probability by looking at what might happen when we toss it. Okay, so when I throw a dice, it can come up as either a 1, 2, 3, 4, 5, or 6. Assuming the die is fair, any of these outcomes is possible. So what's the probability, say, of rolling a 2? Well, intuitively, I think you know what that probability is, but let's roll the dice and see. If you said that the probability of rolling it was 1 out of 6, or 1/6, then you're correct. In fact, the probability of rolling any face is 1 out of 6. What's the probability of rolling a 1, a 2, or a 4? Well, if you said 3/6 or 1/2, 0.5, you were correct. This makes intuitive sense as well. All probabilities, I should say, follow the addition rule. If you add up the probability of each event independent of the other events, that gives you the probability of producing any of the outcomes that you're going to specify. Okay, how about a deck of cards? Let's consider a slightly different problem. There are 52 cards in a standard deck. What's the probability of drawing a queen of diamonds? Well, there are 52 cards in a standard deck, as I said. There's only one queen of diamonds, so the probability of drawing the queen of diamonds is 1 divided by 52. It's useful to know, by the way, that since there are 4 queens in the standard deck of cards, the probability of drawing any suit of queens is 4 divided by 52. Again, that's just the addition rule. Either, in other words, what we'd be saying is a queen of diamonds, or a queen of hearts, or a queen of spades, or a queen of clubs. Okay, so that would be 4 out of 52. Okay, so we've drawn out our queen of diamonds, and our deck now looks like this. Okay, now let's ask, what's the probability of drawing the ace of spades? Well, again, the probability of drawing the ace of spades, if we fail to return the queen of diamonds to the deck, is now 1 divided by 51, since there are only 51 cards in the deck now. Of course, if we put the Queen of Diamonds back into the deck, then the probability of drawing an Ace of Spades is again 1 out of 52. Determining the probability of 2 events occurring together follows a different rule. It's called the multiplication rule. To find the probability of 2 events occurring, in this case, we multiply the probability of one event occurring by the probability of the other event occurring. I've done that here in 2 different ways. Once with replacement and once without replacement. You'll notice that the 2 probabilities differ by only 1/100,000th. So for small samples drawn from relatively large populations, whether you replace or don't replace doesn't make that much of a difference. But you can see here the multiplication rule in action. Okay, let's go back to our dice for a moment. What's the probability? Take a look at the dice here. What's the probability of rolling a 7? Well, a 6-sided dice doesn't have a 7, so there's 0 probability of rolling a 7. What's the probability of rolling a 1, or a 2, or a 3, or a 4, or a 5, or a 6? Well, again, we'd use the addition rule. The probability of rolling any one of those possible dice winds up being 1. Again, the addition rule. So let's summarize. Probabilities can range from 0 to 1. You can't have a probability greater than 1 or a probability less than 0. The probability that any combination of particular events will occur follows what we call the addition rule. To compute that probability, add the probabilities of each individual event. The probability that a specific combination will occur follows the multiplication rule. To compute that probability, multiply the individual probabilities of each individual event. Multiply all those individual probabilities together. Okay, that's a little background on probability. The next thing that you'll want to do is see how probability figures in with the normal distribution. And you'll find that in the next movie.